Hello, everyone. My name is Alex Sweetser. I'm the Director of Technical Alliances here at Sedai. Welcome to our Lunch and Learn for optimizing AWS Lambda for cost and performance best practices in 2023. And joining us today, Nicole, if you want to go to the next slide. We have Maya Flores, Partner Solutions Architect at AWS, as well as Nikol Gobanov, a VP of Engineering here at Sedai. And what we'll be going over today, we'll quickly introduce the AWS and Sedai partnership, and then dive right into foundational knowledge on Lambda, and then jump over to some best practices from both an AWS and Sedai standpoint on how to optimize Lambdas for cost and performance. And then we'll jump over to Q&A. At any point, if you do have questions, please put them in the chat and we'll grab them and try and answer them as real time as possible for you. So Sedai is an AWS partner. We are Lambda ready, service Lambda ready, and actually work with the development teams over at AWS and develop our products together. We're also ISV Accelerate, as well as in the Global Startup Program for AWS as well. So Maya, I'll pass it over to you, who's going to go through some of the foundational knowledge from the AWS side on Lambda.
Awesome, thank you. So I'm going to kick it off with a brief overview of Lambda and how your Lambda functions execute. So Lambda is a service that runs your code in the cloud for you. It removes all the complexity of infrastructure and operations management. And your code is executed in what we call a Lambda execution environment. One really key thing to keep in mind here is that this execution environment is ephemeral. So depending on traffic patterns, a Lambda function can be invoked thousands of times a day. And what that means is that execution environments are constantly being created, being reused for some period of time, and then being destroyed all the time. So I'm going to walk through kind of each step in this life cycle. So first, when Lambda receives an incoming event to process, it will look for an available execution environment. If it finds one, great. It'll invoke your handler code and your function will run. This is what we call a warm start, if you can see on the graphic here. But if Lambda receives an incoming event to process and it looks for an execution environment and it doesn't find one, it will have to create a new one. And so when this happens, Lambda will need to download and unpack your function package. It will need to create a new execution environment. It will need to execute the function initialization code, and then only then does it execute your handler function code. This is something that we call a cold start, and we're going to talk a little bit about this later. So a single execution environment can process only a single event at a time. If your function runs for, like, say, 100 milliseconds, it can process 10 events in 1 second. But what do you do if you have multiple events incoming at one time? In that case, Lambda will stand up multiple execution environments to invoke your function multiple times. And these all are processing events concurrently, which is why we call it Lambda concurrency. But in our largest regions like North Virginia, you can have up to 1,000 concurrent executions at the same time. But depending on your business case, you may need way more than that. So we can bump that all the way up to tens of thousands of concurrent Lambda execution functions. One thing I want to note here is that each execution environment is fully isolated from every other execution environment. Once an event is processed, the execution environment, sorry, that's such a tongue twister, it's frozen. And then once it receives a new event, it will be thawed out, it will process that event. And then if there's more events, it'll process those. If not, it will be frozen again. So the cycle kind of continues on. After some time of either prolonged inactivity or it's just been a really long time, the execution environment will be shut down and destroyed. So I'm going to pass it over to Nikhil.
Thank you, Maya. And so what we'll go through next is some of the best practices that we have learned over a period of time working with Lambdas and optimizing Lambdas in production environments. To kind of level set this, uh, what we're going to see is look at the best practice and see what are the options, what are the tools that you have at hand to adopt those best practices in your organization. There are some manual tools, some manual steps that you can do. So there are some automation steps you could do, and there are some autonomous options as well available to you. So with that a pattern, what I want to initially level set is call out this distinction between automation and autonomous just a little bit, right? So typically when you when you manage a system in production, you ways to automate your process, right? So how can you get ready manual toil for doing certain things like managing operations and things like that, right? So you write scripts for that, right? The manual steps that you have learned over a period of time, and then put it in an execution environment, right? Now, one of the challenges with that is you have to constantly manage this automation that you build, or if the environment changes, things might break, and you are setting things based on predefined heuristics, right? But automation still definitely is very useful, right? It reduces the manual toil in doing a lot of these steps to manage your environment. Now, the next slide, what you'll see is how does this contrast with with autonomous systems. What autonomous does in addition to being to doing everything that automation does is it's not just the steps that's important when you do something in an autonomous mode. It's the goal, right? So it's the steps are kind of secondary to get to that goal. So you may get to a certain goal through multiple steps, right? And an autonomous system figures that out for you, right? And adjusts when the environment changes. It evolves with the dynamic environments, and it adapts to all those changes. So this is a subtle distinction between automation and autonomous systems. So automation is a series of steps that you define. Autonomous is a system where you define a goal and let the system handle that for you. A kind of good comparison would be when you talk about self-driving cars or automobiles in general, right? You might be used to cars that have lane keeping assist, or manages your speed when on a freeway, right? Those are automation, right? And at any point of time, you will still be able to take back manual control, and if environment changes, you are expected to do that. Versus a true autonomous self-driving car, you just give in an address and just sit back and relax, ideally, right? That's the goal. So that's what autonomous system means, and that's kind of what we'll see through as we go through the different best practices in the next set of slides. So next slide, please. So okay, so the first best practice that we're going to talk about is about managing SLOs and making sure your priorities are aligned with business goals. So next slide, you'll see that what is the reason to have an SLO? For any business or for any technology to survive, the most important question is, does it solve a valid business problem, right? And if it does, how do you define the effectiveness of that solution? And this is where SLOs comes into play, right? So you build a solution, you put it out there. You have to actually work with your business to understand what are the objectives that they want out of your solution, right? So it's very critical that you actually define those SLOs for any technology in general, but Lambdas in particular as well, right? You need to understand what are the goals that business is trying to get to from this solution. Now, tools such as looking at metrics from CloudWatch or even from other monitoring providers takes you one step towards that goal, right? So you can look at what are the metrics that business really cares about, and now you can put thresholds around that. You can put alerts around, oh, well, this metric or this performance or something, right, is not up to business standards. Now you can act as owners of the solution to make that better for the customer and for the end users. So tools definitely help you. So some of these tools definitely help you manage in these SLOs. Now when you pick up SLOs, you also have to be aware that there are effective trade-offs you might be making, right? Sometimes you want the best performance, sometimes you want the best cost, sometimes there are other business metrics that's more important than either of those, right? So being aware of what is it that your business is trying to achieve is very critical for you as the first step, right? So in the next slide, you will see some of one of the other solutions that Sedai offers in terms of autonomously managing your SLOs. What Sedai does here is it looks at your once Sedai understands your environment, it looks at all your metrics and say, well, these are performance or usage or business metrics that might be relevant to your business, and Sedai configures that for you out of the box, right, autonomously, and it also tracks those metrics and sends you alert when those metrics are kind of not met, or when those objectives are kind of being hard to achieve, right? So now you can work with your business and then reset these SLOs again. So you and as someone who's owning this infrastructure or the solution, and the business has to focus on the metric itself rather than the process of setting it up, right? So that's one of the things that you could do with an autonomous solution that helps you manage SLOs. Next slide, we will see and the next step in managing your lambdas is to make sure you actually look at the right metrics. Okay, so now business has told you what they want, but you need to realize what metrics should you actually look at. If you use CloudWatch or if you use other monitoring providers, there's a huge list of metrics that's available to you. And always the difficult choice is finding what are the metrics that really matters and how do you actually monitor, what are the thresholds for those metrics. Now, Lambda is uniquely placed here because there are very good standard metrics that comes out of Lambda, unlike, let's say, container-based solutions or your typical multi-tier applications, right? So there's a rich set of standardized metrics that Lambdas provide you. So start with those, right? Those are your good golden metrics. It has traffic, it has duration, it has errors, right? So all the good things that you really want to know is out of the box with CloudWatch. Take that and now analyze those and understand what are the thresholds that you really care about, right? And then start to think about, okay, now how do I actually measure this? How do I set up the thresholds? And how do I effectively track these metrics? So that's once you do that, then you know what you're monitoring, and then what is the value of those metrics that you get. Right? Step 2 after that would be actually refining those metrics, right? For different scenarios. Some lambdas, for instance, might be very performance sensitive, right? So you really care about the duration and the performance of those, versus some could be just a batch-based operation. You really don't care much about performance in those cases, right? It can run longer as long as it just completes executing normally without errors. So those are the kind of decisions you have to make and the things that you have to think through when you choose the right metrics. So again, this is a process which requires expertise and awareness of your environment. And this is again one place where an autonomous solution like Sedai can help. Like in the next slide, you can see that Sedai can autonomously pick up the right metrics for you, right? So we Sedai understands what are the traffic metrics that's coming out of CloudWatch for Lambdas, for instance. Are we getting a duplicate of that from, let's say, another monitoring provider or from an APM solution? It combines those and collectively presents a standardized metric for you. So this way, again, it takes off that extra burden of understanding these metrics and presents this in a nice little manner for you to start consuming. So moving on to the next slide, we can talk about the most critical, one of the two most critical things you would do when you're managing Lambdas, which is on managing it for performance and managing it for cost. Now, combining this, you can call it as the right sizing of your function, right? Like we said, you obviously want to run your Lambdas in the best possible manner. So your SLOs are set, you are monitoring your metrics. Now, what is the right combination of settings that you need to do so that you get the right performance, the right outcome out of this? Now, the two typical outcomes that you want to talk about from an operational point of view is the performance, right? How fast is it running? Is it meeting all your SLOs and needs? And the other one is it running in an optimum point of view in terms of cost? So identifying the right combination of memory and the setting is one of the critical things that you would make as a part of this assessment. And you have to do this on a continuous basis, right? Typically, what we see is developers set a Lambda at 128 MB while development, right? And then that makes all its way into production. And unless there is a very concerted effort to manage it, people leave it at that. There's quite a few risks associated with that, right? One is that's the lowest possible memory and computing power that you can throw at a Lambda. Is that the right one, right? There are other settings pretty much in all cases where you get better performance and better cost, right? And we'll see that in the next few slides. And monitoring that continuously, right? You make this move things into production, and now things change over a period of time. You get multiple releases every week, right? Or your traffic pattern changes, your downstream API changes. So there's so many things that can impact your production Lambdas, and you have to continuously stay on top of that. So what you're seeing in this slide is the most important knob that you have here to control the performance and characteristics of a Lambda is the function memory, right? So you start with 128 MB, and you can go all the way up to a little about 10 gigs of memory that a function can take. What AWS does behind the scene is also, as you increase the memory, it increases the amount of CPU power or the compute power that your Lambda has. And at certain points, there are thresholds where you have multiple CPUs or vCPUs available for your Lambda to act on, right? So this is the singular knob you have in terms of controlling the functional the function's execution parameters. And although this sounds very deceptively simple, there's a lot of thought that needs to go into when you adopt this, when you make changes to this. So moving on to the next slide, you can see how the memory and the execution time, right, can impact your duration and the cost. So the duration itself is a function of the memory that's available for your Lambda and the execution time that every invocation takes, right? So that's how the duration obviously is calculated, or the actual resource usage is calculated. The cost that you incur is also a function of the duration and the number of invocations, right? So eventually, from a performance point of view, you want to manage the memory consumption of the Lambda, which in turn affects the cost. You want to control the latency or the duration of execution of the Lambda, and also obviously you want to manage the throughput. You want to make sure no calls are throttled, and all customer invocations of the Lambda are properly served, right? So to the next slide. Sorry, we have. Looks like we lost the slide, but I'll continue. I think we'll get to it. There we go. Yes. So one of the tools, right, we'll see is that you have for managing the performance of a Lambda is the AWS Compute Optimizer. So if you go to the AWS console, you should be able to see recommendations that AWS directly gives you based on the memory usage and patterns, right? So there are recommendations like you see in the slides, right? So this is from the Compute Optimizer. So in this case, you can see that AWS is saying your Lambda is probably over provisioned, right? You might be putting in more memory than needed, and might be a good option for you to revisit that, right? Now, the exact choice that you need to make here is totally up to you, right? This is just a recommendation. Do you want, if this is very critical and you're okay to have it a little bit more over provision, that's a decision you have to make. Or you really are focused on cost and you really want to bring it down to a more optimized provision level. Again, those are choices that you need to make as owners of this environment. Now, if you jump to the next slide, what you see here is more tooling around that, right? So using the Lambda Power Tuning open source tool, this gives you a now much broader view on the memory and the performance of Lambdas. So if you follow the red line or the red graph here, right, it's basically telling you as you increase memory, your execution time actually goes down, right? Not very surprising, right? Because we already established that as you increase the memory, the amount of compute power available to your Lambda also goes up proportionally, right? So the more memory you add, the more faster it gets, right? So that's what the red graph here is telling you. The blue, on the other hand, is telling you that as you increase memory, and your cost is going down up to a certain point, and after that the cost goes up. This may be a little counterintuitive to some people, and the reason is you would expect that as you add more memory, your cost is going to go up, and that's not true most of the time. as you add more memory, your performance also does increase, right? And as your performance increases, the execution time, the time that you spend consuming these resources, goes down proportionally. So it's a delicate balance between increasing the memory to a point where you realize that you have the best performance at the best possible cost, right? So that's what the lowest point in that blue graph would be telling you, right? At that point, you have the lowest possible cost at the best possible performance, right? Now that is an optimization problem, right? And this Lambda Power Tuner gives you those recommendations. It tells you what is your best performance, what is your best configuration of memory for all that. And again, as an owner of this environment, you will have to kind of follow this recommendation and now go execute this manually or build some automation to do that for you, right? And again, keep in mind you have to do this for most of your Lambdas and do this on a continuous basis as you get more releases and code is deployed into production or downstream environment changes. So there are a bunch of things that you'll have to do to make sure that these recommendations are met. An autonomous solution, on the other hand, like what Sedai does here, is autonomously do that for you, right? So instead of making those decisions every time those recommendation comes in, you just have a one-time job of saying, okay, turn on autonomous and let an autonomous system like Sedai figure this out for you. So by default in Sedai, the optimization target is always best of both worlds, right? You are getting the best. Sedai tries to optimize the Lambdas so that you get the best possible performance at the best possible or the lowest possible cost, right? So that's a default configuration and the default optimization target. Now, what you see in the next slide is that some cases you have real-time Lambdas, right? You have a Lambda that's doing checkout services on an e-commerce website, or adding something to a cart, or processing payment, right? These are all very critical APIs, right? Which you want to have the best possible performance. So for those cases, you would make a choice and say, well, I don't care if this costs more, right? This is a critical Lambda for me. Anytime you see any pattern here, you want to make sure this meets this performance SLO, and it's okay for me to pay more, right? Even if you charge 25% more on execution for these Lambdas, I'm okay, because I want the best possible performance. So you just set this as a setting for this Lambda in an autonomous system and let the system actually figure it out, right? It figures out the best possible memory combination, keeps track of the traffic and the downstream system, and then eventually say, okay, now this is what it looks like, and let me re-optimize it, right? So it does that on an ongoing, continuous basis, and that's the stated benefit of autonomous system. Contrasting that, in the next slide, you'll see that there could be batch-based applications as well, right? Like I said, in these cases, you don't care if it takes 1 second versus 1.5 seconds to deliver an email or an SMS, right? It's still within the range of acceptable duration, right? So in those cases, you are willing to compromise a little bit on performance and say, okay, you know what? Let this run as cost efficient as possible. And so that's another setting and an optimization target you can give to a autonomous system and say, let that take care of it, right? Let the system figure out the best possible combination for that target and hand it going forward. So continuing on now, so optimizing on cost and performance are definitely one of the biggest decisions you have to make in operations. The next one would be cold starts and concurrency management. Now, cold starts, like Maya mentioned earlier, is something that you experience for the first invocation of a Lambda, right? When the Lambda is being woken up and provisioned and put into memory, right? So the first invocation of a Lambda would experience a cold start, right? And based on the concurrency, let's say if there is 15 concurrent users, you might have 15 customers who might have experienced a cold start, right? And cold starts could mean different things for different kinds of applications, right? All APIs or all Lambdas might not be cold start sensitive, right? Some you don't care if it's a batch-based application, you don't care if there's a cold start, right? As long as it continues and completes. But for the ones where you actually care about cold start, where the customer experience is very important, you have to use some solution to manage that. One of the out-of-the-box solution that AWS has is to use provision concurrency. So provision concurrency allows you to allows the functions to respond without the cold start, right? It kinds of keeps it pre-provisioned for you, right? So, but to set up provision concurrency, you have to kind of understand what your concurrency patterns are, or use auto scaling within AWS to manage that for you. But you have to set up those thresholds, and understanding those thresholds, unless your product or application is in production, is a little hard, because you need to know what is your concurrency patterns, what is the behavior, right? So once you set that up, then provision concurrency kicks in whenever there's increase in concurrency, and that gets managed. Another option that you have for managing cold start is the very recently released Snapstart option with Java-based Lambdas. So what
I can
this
talk a little bit about this if you want.
Yeah, sure, go ahead.
Yeah, absolutely. So Snapstart was released at reInvent 2022, and essentially AWS has seen a pattern where historically Java or Lambda functions with a Java runtime have had the longest average cold start time, and we knew this was a pain point for customers, and so we created AWS Snapstart, which actually allows Java-based functions to start up to 10 times faster than previously when they experience a cold start. So essentially the way that it works is that it will initialize your Lambda function ahead of time before anyone ever invokes it, take a snapshot of the entire micro VM that your function is running on, and then we'll cache it for low latency retrieval. And then each time your function is then invoked, it will retrieve that snapshot, restore your function, and run it there. And with this, we've seen extreme increases with latency up to 10 times. And it's totally free, low code changes or no code changes. It's a really cool new feature. But yeah, thanks, Nikhil.
Yeah, sure. No, thanks for pitching in, Maya. And feel free to pitch in any point. So Snapchat definitely helps you in speeding up or reducing the effect of cold starts on a lot of Java-based Lambdas. Now, what Sedai does on top of this is to again, the same story here, right? Helps you manage concurrency in a more autonomous manner by looking at traffic patterns. So if you go to the next slide, we see that some of the things that an autonomous concurrency management system could do for you, right? So Sedai autonomously manages your provision concurrency and your reserve concurrency as well, right? So those are the two kind of concurrency knobs that you have to you can play around on Lambdas. Now, the way Sedai does this, Sedai looks at your the traffic pattern of the Lambda, recognizes that these are the point of time where concurrency is going to be high, and if concurrency is going to be high, it tries to warm up your or to preempt the cold starts by using provision concurrency or using warm-up calls or using a combination of that. So this way, when a customer call comes in, it's already provisioned or it's warmed up, right? Again, based on the traffic patterns and a bunch of other factors that we look at. The best part about this is to turn on this part, you don't have to now look at your concurrency pattern and understand what those settings and thresholds are. You just turn on a literally a checkbox and say that enable autonomous concurrency, and said I will do all of this autonomously behind the scene for you. And this also does not involve any code changes, right? I mean, if you go for traditional warm-up calls or warm-up Lambdas or warm-up approaches, you have to plan for that long earlier in the development process, right? You have to add code in the code to kind of handle those warm-up calls. But with Sedai's approach of autonomous concurrency, none of that are needed, right? Concurrency management can be purely an afterthought once you're in production and by just turning on autonomous concurrency. And the other challenge with managing concurrency is you need to always keep up with downstream systems, right? You have to be aware, well, I'm calling an API and now that API is taking twice as long, right? Now that impacts your concurrency, that the levels of concurrency that you might have to set up, and that impacts the experience of the users. Sedai actually factors all these things from upstream and downstream systems, and then comes up with the recommendation for autonomous concurrency and autonomously executes that for you and sets it at the right value. One of the other critical things with managing concurrency is that those are settings you could set up in your IAC or CI/CD tools, right? So maybe an autonomous system sets it up, or you set it up in production, but you have a deployment and that kind of overrides it, right? So this is where you need to have a balance of a tool that actually plays nice with your IAC and CI/CD tool, so that this, even if there are changes, that's not optimal for managing it. it eventually gets back to that optimum, and those that configuration is fed back into your development and DevOps systems. So those are some of the critical things that you have to kind of look at and manage when looking at provision concurrency and managing cold start. The next one is timeouts. Based on your production experience, right? So you set everything up, you have managed the optimize, you have optimized your lambdas, you are set a provision concurrency, but are your customers being timed out? And now setting up timeouts is also a very kind of a conflicting priority, right? On the one hand, you want the timeouts to be short so that your Lambda is actually executing well within tolerance ranges. But at the same time, you want it to be higher so that if there are stragglers because of long-running API calls or other backend calls, you want that to complete in a reasonable manner. So setting also timeout has implications on cost as well, right? I mean, if you set too high of a timeout, you might get some cost overruns because of outliers or unexpected execution, right? Now, how do you manage this again? The typical way to do that would be once your application is live in production, you look at the timeout setting and you compare that with the actual timeouts, right? Look at the P99, the P95, and see where it should be, right, in relation to your SLOs, in relation to the other metrics and the other applications that this might impact. So you have to constantly make that decision on what are the timeout settings that you need, and you have to come up with an optimal threshold. And this has to be, again, just like anything else, has to be constantly revisited as you get new releases and as you see abnormal behavior and abnormal patterns in the behavior. So the next slide, you'll see how Sedai actually helps you kind of overcome this as well, right? When Sedai sees a timeout, it treats it as an availability problem immediately, right? So it reacts by setting a different timeout. Now, this is just one step in that process, because increasing a timeout might not be the ideal solution in all cases. Sometimes it might be you're experiencing a timeout because your Lambda is probably taking too long to run, and maybe that's because you had too low of a memory setting, right? Or you're not throwing enough horsepower at it. So the other alternative would be to add a little bit more memory so that it stays within that timeout. Now, those decisions again are something that Sedai does and can execute autonomously. And it doesn't just execute that as a one-off thing, right? There are many other things that you have to validate, and you have to do a bunch of safety checks, right? You can't just do this in isolation. You have to make sure this doesn't impact anything, right? A change that you bring does not break anything. That's obviously the first goal, right? Do no harm. So you do those safety checks, you acquire logs so that there's no conflicting changes from different places, and then you create the audit task and you audit those changes and capture the release the reasons and all that, right? And so you want to make sure anyone can come back and audit and make sure all these changes were done in a prescribed manner. So those are again some of the things that we do behind the scenes to make sure whenever you execute or experience a timeout, or for that matter any availability issue, things are done in a very safe and a repeatable manner. So moving on to the next one we have here is so something that I've been touching all along, right, throughout the conversation, is getting a real-time view of your deployments and of releases. Changes is an everlasting constant, right? I mean, you cannot expect Lambdas to be deployed and to remain same. Even if you don't do a release, or even if you don't change your code, downstream systems might change, your traffic, your customers, their behavior. This could all change over a period of time. So which is why it is very important that you monitor this and manage this on a continuous ongoing basis. And this is where the release intelligence and the release performance management that becomes a very critical step in this entire process. So anytime something changes, you have to reevaluate your assumptions, you have to reevaluate your thresholds. This has to be communicated out of band with the development team, right? So the moment you see that a release has brought down or increased the duration of a Lambda, now that has to be something that has to be fed back to your dev team. Right. So this is again a continuous ongoing process that needs to be done, and where we see a lot of customers is that although they manage and look at all the thresholds and the metrics, it's not tied into the releases, right? So you need to know when is a release coming in, when a release is made and what is the downstream impact of it. Is there a nice dashboard to visualize that? Second, one of the things that with Sedai's release intelligence platform, we continuously monitor your releases. We build a nice dashboard about every single release, and we also give every release a score between 0 and 10, right? 10 being, okay, well, everything looks exactly the same after a release, right? No changes, no performance degradation, no cost overruns, or no increase in errors. The moment we see that something changes, then we reevaluate that. And based on how we want to treat that, we can either remediate it by, let's say, adding more memory or making things run faster, or just sending a notification to the developer saying, hey, you just released this, and after this release, we are seeing significantly increased resource usage in this particular case, right? So these kind of things has to be done on an ongoing basis, and this is where an autonomous system can help with that. I think I just saw a question flash by. Was there a question? How to operate the... so the question here is how to operate the determining signal feature. I'm assuming that means how do you look at the, how do you get the signals, how do you get the recommendations, and how do you operate on that? I'm assuming that is the spirit of the question here. So to get a signal, it's there's quite a few things that needs to happen, right? One is you need to know the existing pattern, right? So you need to have observed a resource historically to know, well, this is the standard pattern of operation for that, right? Let's say an e-commerce website, right? Your traffic peaks, starts trickling in after, let's say, 9 a.m. and slows down after, let's say, 10 p.m., right? And during the night hours, you barely see any traffic. So assuming that's a pattern, right? So you have to learn that pattern, and you have to learn that pattern for days, and also you have to learn that for weekends and so on, right? So there's a bunch of seasonality considerations that you need to make and learn those patterns. Now, with those patterns, then you have to track what should be the outcome, right? So this is how your traffic changes, but what is the typical performance in those situations, right? And now you have to kind of determine those baselines. Once those baselines are established, now you can start managing. You can start looking at when are those thresholds crossed, right? When are those SLOs breached? And based on some heuristics there and some machine learning model driven recommendation, you decide that things have changed now, and now this is a high priority change or a big signal that has the potential to impact your signal, your system, right? And then based on that, make decisions. So there's a lot of other processing, looking at metrics, looking at seasonality patterns, looking at what is typical behavior that you establish those kind of signals.
Okay, great. So now I'm going to talk about our seventh best practice, which is how you can leverage low-cost processors for your compatible workloads. So Graviton2 is AWS's second generation custom-built 64-bit ARM processor. It was built with the goal of offering the best cost performance. And so you can use this for your Lambda functions. And we're seeing that Lambda functions that use Graviton2 are getting a 34% better price performance. Lambda pricing for Graviton2 is based on duration, but it is priced at 20% less than 20% less than regular x86 based processors. And this holds true with provision concurrency as well, so you can use this there. So adding that 20% less price point on top of the faster execution times with the chip gives you that 34% better price performance. And Graviton2 is really better for kind of specific workloads. We really recommend it for any workloads with multi-threading or a lot of I/O operations, CPU-based ML inference, video encoding, log processing. Those are really the best workloads for Graviton2. But if you wanted to try it out for yourself, you can use the Lambda power tuning tool that we talked about later to compare your current Lambda function on the x86 processor with the Graviton2 version of your function. And you can kind of see how they perform in reference to each other and to kind of pick out which one is the best. You can also switch from Graviton 2 to x86 with little to no code changes, and you can switch back as well. So it is a two-way door. You can switch between the two, and it's just a switch you can flick in the console. Okay, and so the next best practice I'm going to talk about is using tracing to drill into performance issues. So everything we've talked about previously has kind of been about how to optimize your functions kind of from the outside and the configuration. But we know that the code inside of your function also has an impact on optimization and performance. So I'm going to talk about some tools that we can use to kind of address that. So the first one is an AWS tool, AWS X-Ray. It allows you to do distributed tracing on your applications. You can enable it and it will look at what's directly in your application code or even external resources that are interacting with your Lambda function, and you can trace through the entire process. The next service is Amazon Code Guru. This is a service that uses machine learning models that are built on decades of Amazon knowledge and experience. And so it provides automated code reviews as well as application performance profiling, and it will identify the most expensive lines of code that you have and will give you recommendations on how to improve that and improve the quality of your code. And then finally, I want to talk about the Lambda telemetry API. This is also a new release. It was released in November 2022. It essentially provides an easier way to receive enhanced function telemetry directly from the Lambda service. So it makes it really great for developers and operators that use third-party observability tools to monitor and observe their Lambda functions. And so I want to shout out Sedai for being a launch partner for the telemetry API. They use it to improve the performance of your Lambda functions by gathering insights about your functions and providing recommendations for you to either remediate or use their autonomous remediation. Through the Lambda telemetry API, they can get information like if a cold start occurred or the exact execution time of your Lambda function. And so this is a screenshot of AWS X-Ray. This is a Lambda function kind of invocation. And so we can see here, there's two things that I really want to point out. And the first is that the initialization is taking a very long time. But we know that that only happens during a cold start, so that may not be as big of an issue as we think. The second thing that I want to point out is SQS. The function is spending 143 milliseconds invoking SQS, and that can probably be optimized. One easy way that it may be optimized is by moving that invocation from your handler code into the initialization code. Since that initialization is only happening when there's a cold start, it won't be done every time your function runs. It'll just be done in that initial first run. And so that can save you some time. And then this is a screenshot from Code Guru. This is a example call graph, and it kind of represents the execution cost for this code. You can hover over each part of your function code. You can further understand what each block and each line of code is doing on your executing CPU, as well as a dollar estimate for that line of code. And so you really can focus on where your time and efforts are best spent optimizing your code, and you don't have to worry about the other stuff.
Okay. Thank you, Maya. Thank you, Nicole. We're going to open question and answers here. So if you do have any questions, feel free to put them in the chat. We do have a few from the presentation that we can start with. So how safe are autonomous systems for these kinds of use cases? Nicole, I'll toss that one to you.
Yeah, sure. So yes, when you have an autonomous system to take care of anything, right? Obviously, safety should be your most important criteria, right? You don't want to get into a self-driving car if you don't feel comfortable and if you don't feel safe. So obviously, that has to be the structure and the framework around which your entire solution is built. And within Sedai, that's kind of the framework that we have built the entire product on, is to make sure the first principle is do no harm, right? So you have to, every decision, every action that Sedai does autonomously is very thoughtfully done in terms of thresholds that's internally monitored in the decisions that's taken, the feedback loop that's executed, right? So even if even if an action is done autonomously, there are checks and balances to make sure in the short term and in the long term to make sure that that's actually working as expected and it's not causing any downstream harm or harm at a future point of time. Now, to add to that, as a customer who's or as a potential user of an autonomous system, we don't expect anyone to get to start using autonomous on day one. You use an autonomous system only once you have built trust, right? So our process of using tool like Sedai is also based on that process, right? It's a crawl, walk, run life cycle. You get gradually acclimatized to the things that an autonomous system can do. On day one, everything is just a recommendation, right? You choose that I don't trust you yet, and so show me what you could have done, and show me what you would have done, how you would have handled the scenarios. And then once you see that, and then gradually you build that trust and hand over more control to the autonomous system. So it's more of a process, a journey, than a decision that you make and then execute immediately in terms of getting to use an autonomous system.
Great. Thank you, Nickel. Maya, I'll throw this one to you. How do you do tracing for distributed environments?
Yeah, thanks. So Amazon X-Ray, that service that I just kind of talked about, is our service for doing distributed tracing. Allows you to see what's going on inside as well as in between your different application components. And so you can get a very accurate picture of where the bottlenecks are in your application code or in different application components. And so I don't have a screenshot of it, but it will give you an entire kind of this application map, and you can view it from kind of a bird's eye view, and then you can click into each part of your distributed application and view information on that. And so you can really drill down.
Great. Thank you, Maya. And are there any best practices for scaling across regions? So I'll kind of toss that to both of you, whoever wants to answer.
Yeah, I think when we're talking about Lambdas in general, one of the one of the easier decisions there is if you deploy the Lambda across regions, you could deploy your Lambda across regions and closer to where your customers are, right? And as long as you have architected the backend so that it's scalable across regions, that should be pretty much it from a scalability point of view, right? So Lambda makes a lot of that scaling across regions easy for you, especially when you are deploying on the edge or just using functions to serve endpoint or end user APIs. On top of that, I'm sure there's plenty of other best practices that AWS has based on the architecture of your application, infrastructure, and a bunch of other needs, right? It's hard to, I guess, generalize, but Maya, I'll let you.
Yeah, I can give kind of 3 main pointers, although this could be an entire webinar in itself, I think. First thing that we recommend is always use infrastructure as code when you're scaling out between availability zones or regions. It makes it really easy to have a repeatable template that you can deploy consistently across environments and regions. Next is kind of using event-driven architecture. Ensuring that your components are more loosely coupled means that, if you have a failure somewhere, it's not going to impact everything. And so you can kind of architect for that. And then third is that when you're architecting across large areas, it's really important that your monitoring and observability are key. You need to know what's going on in each region at each time. And so your monitoring and learning need to be really well set up.
Thank you, Maya. Next question. What are some KPIs that are important to track when implementing autonomous systems in an organization? Nicole, I'll start with you.
Yeah, sure. So with some of the important KPIs with autonomous system is, first of all, it starts with what are the goals that you have out of your autonomous system, right? So We've seen equal amount of customers who focus on cost and the ones that focus on performance. So based on what your appetite for or what your goals or objective with the autonomous system is, you start with that, right? So definitely monitoring both cost and performance. Even if it's your focus is on cost, you want to see what is the downstream impact on performance because of your focus on cost. So those will be the two most important things that you would start to manage and look at from a very high level point of view. But as you go dig deeper, right, then you can start looking at more other KPIs. So for autonomous actions, right? So we kind of divide it into groups when it comes to Sedai. There's things that you do for optimization, and then there are things that you do for availability to make sure that nothing's broken, right? So when it comes to optimizations, the number of optimizations that you do, what is the impact of those optimization? What is the cost reduction because of those optimization? What are the number of actions that you took, right? So those are kind of some important metrics that you use to track that. From a performance point of view, or from a availability point of view, we look at what are the potential issues that we identified, right? Like out of memories or timeouts. What are the things that we actually saw? What were the things that we anticipated and proactively remediated even before we saw the issue actually manifest and become worse? And then the last one is how many did you fix after the fact, right? So how many issues did you actually see and autonomously fix it? And the meta KPI on top of this is how does those KPIs trend over time, right? You want to see the amount of proactive actions increase over time and the amount of reactive remediations decrease over time, right? So those are some of the KPIs you would need to kind of monitor for an autonomous system.
Great. And Maya, I think you covered a section of this prior for moving some of the code to the initialization stage to reduce cost. Are there other things a user can do to reduce or kind of enter into low cost deployments?
Yeah, absolutely. So there's a lot of best practices around how you should really be structuring your Lambda code. First is, like I mentioned previously, you want to move as much code as you can from kind of the body handler code to the init, because that's going to be happening once every invocation, and then you don't have to worry about that taking up time. Another thing that we really recommend is that with Lambda functions, you want to keep them as small as possible. You don't want big monolithic Lambda functions that are running for 15 minutes. So really what you should be doing is kind of just doing your core business function, whether it's data transformation or something like that. You don't want to be querying data in that Lambda function from S3 and then transforming it. You want to already have the data when the function is invoked as the input event coming in. And then, so you're only really doing your core business function as a part of the handler code.
Yeah. And a couple of other things that we have seen with our customers in production is, similar to what you said, Maya, like if you make API calls within your Lambda and that API call is not something that you can actually control, right? So then you're spending your Lambda execution time and the budget and the cost on waiting on something that's just going to take a fixed amount of time, right? So if you architect or kind of change the way you build your application and make it more event driven, that definitely helps in speeding up a lot of those things. And another area where we have seen customers take a lot of improvement here is by using step functions to kind of build out the workflows and make it more event driven. So those are a couple of other suggestions we have seen that work for customers.
Yeah, absolutely. Don't have kind of the routing inside of the function, either do it with the destination or do it with some other orchestration, not within the Lambda.
Great, thank you. And can we separate the Lambda handler from the core logic? So I'll leave it to you. Who wants to grab that?
I guess there's multiple ways in which to interpret that question. One option is if you use layers for building out your functions. So if the core logic is something that you can put in a logic in a layer and let the handler be a simple execution that helps you separate out the logic or your deployment architecture, right? So that's one way to handle that. But I don't think there's a very general way for answering that. It really depends on how do you want to do separation and what are the specific nuances of your scenario. You want to add to that?
No, I would second that.
Yeah.
Great. We have 5 minutes left. Are there any last minute questions we can answer? Give it a few seconds for anyone to put it into chat. Are you GDPR compliant? So I can actually answer that one. Currently, we're primarily operating in the United States. So we are SOC 2 Type 2 as well as CCPA. As we expand into the EU, into those markets, we're definitely looking to become GDPR.
Yep, and just to add to that, right? So most of the data that we capture and monitor are just metrics. That's not, there are no PII involved. There are no logs or analysis that, at least from a Sedai point of view, that we look at, right? So it's the surface area there is very lean to begin with.
And what do you think about hexagonal architecture within Lambda functions?
Well, I have to say that's a new term for me. I'm not too familiar with what a hexagonal architecture means. I know, if you're familiar with that.
Yeah, I'm actually not super familiar with hexagonal architecture either. That'll be a new term I'll look into.
Okay. Why don't we take that one offline, and if we can get you an answer, we'll send that over to the user who posted it.
Sure.
Any context with open telemetry? I think we've addressed this exhaustively during the presentation and some of the questions. Is there anything you would want to add? Okay. Can we put up the slides for the lunch and learn information? So here is the URL to get your $40 DoorDash lunch on us. All you have to do is complete a very quick survey, just a couple of questions there. And then we'll send you the code so you can get your lunch. But we want to thank everyone for joining today and the engagement. There are a lot of great questions, so thank you all. The recorded video of this we will post after the fact so you can rewatch. If you have any questions or you want to try a free account or a free trial, feel free to visit sedai.io/sign up. Or you can book a call or a demo with us to learn more before you get started. So thanks, everyone.